Okay. So yesterday we talked about permutations, and that's where you have a certain number of choices and you're picking something and you want them to be in order, right? You actually care about the order. And a combination is when you have a certain number of choices. You want to pick some of them. And you don't care about order. Okay. Does anybody know what it means to bid for a project in construction when they're getting bids from companies? Andon?
Yeah, it's like when it's like you have like multiple companies that want to have like a construction site, construction company do their job, and so they're putting up higher prices for just going and going until they finally pick one.
Right, but they're not actually going higher prices because companies are trying to compete with each other. So they're actually going lower and lower prices to say, well, we can do this job for $500,000. And then another company says, well, yeah, but we could do this job for $490,000. You know what I mean? And then, so sometimes they go with, have you ever heard the phrase, go with the lowest bidder? That means that you're going with the cheapest option, which is not always the best choice. Sometimes you have to go with somebody who has more reliability and experience, and you know their company. So the State Department of Transportation plans to develop a new section of interstate highway and receive 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 building companies, or bidding companies? So, does order matter here? We've got 16 companies, we need to pick 4 of them. Does it matter which one's first, which one's second, which one's third or fourth? No, that's why this is a combination and not a permutation. So here's how we would do this. We would essentially do what we did before, which was 16 factorial. Do you remember what would be on the bottom? 12 factorial, right? Because you did 16 minus 4 on the bottom. So we would have that 16 times 15 times 14 times 13. But then we're also going to divide, so wait now. We're also going to get rid of any order that we would have had for those 4 things. So we're also going to divide by 4 factorial. And that is not the same thing as 16 factorial on the bottom. So in your calculator, you are going to take this divided by this. It's under math and probability. I got 1,820. Did you guys get the same thing? Now, what would you think would be more if we cared about order, or if we don't care about order?
If we don't.
If we don't care about order?
Yeah, because if you do care about order, like let's say, I don't know how you would do this, but if you don't care about order, it's more loosely, you can have more combinations, but if you do care about order, it limits it to.
I don't think so. What do you think, Michaela?
Well, because like if we're doing regular, like with order, wouldn't you only divide the bottom by 12, so then
Yep.
you don't care about order, so you wouldn't have to do the 4.
Right. Now let's think of something practical if we can think of a real example, okay? Because it's kind of hard to put your mind around this example. Let's say that I had to send 3 people to the office to go get cookies for all of us. Wouldn't that be cool if I had set this up and there was actually cookies in the office for all of us? I wish I had done it. I didn't. I'm so sorry. Anyway, I know. This would have been a great moment. I'm so sorry I even brought it up. I hated myself as I said those words. Okay. So now we're all disappointed in me. We'll move on. Let's say I had to pick 3 people. And I say, okay, I pick Colin and Alex and Megan to go to the office. That's 3 people, right? That's one possibility I could pick. I could also pick Colin and Michaela and Andon. I could pick Colin and Alex and Emma. I could pick Alex and Jaden and Emma. You know, like there's lots of different choices, right? Okay, but if I had to think about permutations too, it would matter what order I picked. So if I picked Colin and Megan and Alex, then I'd also have to say this is one possibility, right? But another possibility is picking Alex first, then Colin, then Megan. That's another one. I could also pick Colin and then, did I say Alex and Megan? That's one I haven't done yet, right? Megan, Colin. You see how there's lots of different choices here? Those all count as permutations. But I'd only count them as one group for a combination. That make sense, everybody? No. Okay. All right, so let's try this one. The manager of an accounting department wants to form a 3-person advisory committee from the 20 employees in the department. How many ways can the manager form this committee? Does it matter what order we pick these people in? No, we just got to pick 3 people. Here's when it would matter. Look at me. If there's a question in your book where it says they're trying to find a president, a vice president, and a secretary, that means order matters because the first person is the president. It's not like when we vote for people to be the president and the vice president of the United States, it's not like we're voting for 2 people and then they show up and we're like, okay, so which one of you wants to be president? Like, we know, right, which one we voted for to be. The permutation matters. The same thing with a race. Anytime it's a race, first, second, third place, order does matter. It'd be pretty dumb if I was like, hey, who won the Kentucky Derby? And I named the top 3 horses. And you're like, yeah, but who won? You're like, oh, it doesn't matter. Here's the top 3. No, it's a race. It super matters, right? Races, that's the whole point. So, all right, so what we would do is we'd have 20 people in the department, and you divide by what? 17 and 3. All right, practice putting it in your calculator. Make sure you can do it. What'd you get? 43. Okay.
No, 40, sorry.
You guys get the same thing? All right, can anybody come up with a formula here? This is N choose R equals, remember N is how many choices you have, and R is how many you want. All right, so what should I put on top of the fraction? N factorial. For the next bit.
N minus R.
N minus R factorial. And then also R factorial, yep. That's the formula for a combination.